Welcome to Quiet Car Stories. In this video, we'll be looking at a quiet change that has taken place in the automotive world. One that many people have noticed, but few have fully explored. Over time, cars have become quieter, not just slightly, but in ways that have gradually changed how they feel, how they behave, and how we experience them. The sounds that once defined different engines, the rhythms, the tones, the mechanical character, have slowly softened, become more controlled, and in some cases almost disappeared. This is not the result of a single invention or moment in time, but a gradual shift shaped by engineering, regulation, and changing priorities. We'll explore where those sounds came from, why they began to change, and what has replaced them. And as the story unfolds, you may begin to notice just how much of the driving experience has always been shaped, not just by what we see or feel, but by what we hear. In this video, we'll be looking at a quiet change that has taken place in the automotive world, one that many people have noticed but few have fully explored. Over time, cars have become quieter, not just slightly, but in ways that have gradually changed how they feel, how they behave, and how we experience them. The sounds that once defined different engines, the rhythms, the tones, the mechanical character, have slowly softened, become more controlled, and in some cases almost disappeared. This is not the result of a single invention or moment in time, but a gradual shift shaped by engineering, regulation, and changing priorities. We'll explore where those sounds came from, why they began to change, and what has replaced them. And as the story unfolds, you may begin to notice just how much of the driving experience has always been shaped, not just by what we see or feel, but by what we hear. If you enjoy calm storytelling and gentle explanations, please consider liking the video and subscribing to the channel. It really helps support these kinds of long-form, relaxing documentaries. You're welcome to simply sit back and listen. Whether you're here to learn something new, unwind after a long day, or even drift off to sleep, these stories are made to be enjoyed quietly at your own pace. So find a comfortable position, settle in, and let the sound of the story carry you. Let's begin. There is something quietly different about the sound of cars today. It is not always something that stands out immediately. It does not demand attention. It does not announce itself in an obvious way. Instead, it exists as a subtle absence, or perhaps a subtle change, something that feels familiar, yet slightly altered. If you were to stand beside a road many years ago and simply listen, the experience would have been different. Engines would pass with distinct voices. Some would produce a low, steady rumble, others a sharper, higher tone. Each car carried with it a kind of acoustic identity, shaped not by intention, but by the nature of its design. Today, if you stand in that same place, the experience has softened. The variety is still there, but it is less pronounced. The sounds are more controlled, more consistent, and in many cases, quieter. Not silent, but restrained. This change has not come from a single decision. It has not been driven by a single invention. It has emerged gradually, shaped by many small changes over time. To understand it fully, it helps to begin at a point where sound was not something to be refined, but simply something that existed. In the earliest years of the automobile, sound was an unavoidable presence. Engines were simple and often exposed. Combustion took place in relatively crude conditions compared to modern standards. Fuel and air were mixed without precise control. Ignition systems were basic, and the materials used in construction did little to contain or dampen vibration. When combustion occurred inside the cylinder, it produced a rapid expansion of gases. This expansion pushed the piston downward, creating motion. But it also created sound, a sharp, repetitive pulse. This pulse traveled through the engine structure, through the exhaust system, and into the surrounding air. At the same time, the mechanical movement of the engine contributed its own layer of sound. Metal components moved against one another, valves opened and closed, teaming chains rotated, gears engaged. Each of these processes produced vibration, and each vibration produced sound. There was no attempt to isolate these sounds, no effort to conceal them. They were simply part of the machine. Exhaust systems in these early vehicles were minimal. Their purpose was primarily functional. To direct exhaust gases away from the engine and the occupants, there was little consideration given to how those gases sounded as they exited. The result was direct, unfiltered. The sound of combustion traveled almost unchanged from the cylinder to the outside world. This gave early cars a character that was immediate. What you heard was closely connected to what was happening inside the engine. As more vehicles appeared on roads, patterns began to emerge. Different engine designs produced different sounds, not by intention, but by necessity. The number of cylinders influenced the frequency of combustion events. A 4-cylinder engine produced a steady, rhythmic pulse. A 6-cylinder engine smoothed that rhythm, creating a more continuous tone. An 8-cylinder engine added depth, with overlapping combustion events creating a fuller sound. The arrangement of those cylinders also played a role. Engines arranged in a straight line produced one type of rhythm. Engines arranged in a V shape produced another. The timing of ignition, the spacing between cylinders, the design of the crankshaft, all contributed to the final sound. Each engine, in effect, had its own voice. At this stage, sound was not something that engineers sought to perfect, but it was something that people began to notice. Drivers became familiar with the sounds of their own vehicles. They could recognize changes. They could hear when something was not quite right. Sound became a form of feedback, a way of understanding how the machine was operating, and because there was little insulation between the engine and the driver, that feedback was direct, unfiltered. As vehicles became more refined, the relationship between sound and comfort began to shift. While the raw sound of an engine could be informative, it could also be tiring, particularly over longer journeys. As cars became more widely used, especially for extended travel, reducing noise became a priority. Manufacturers began to introduce simple forms of sound control. Mufflers were added to exhaust systems. These devices used internal chambers to reduce the intensity of exhaust pulses. Sound waves would enter the muffler, reflect within its structure, and emerge with reduced energy. The result was a softer exhaust note, less sharp, less intrusive. Inside the vehicle, materials began to change. Surfaces that once transmitted vibration were gradually isolated. Rubber mountings were introduced to support engines. These mountings absorbed movement, reducing the amount of vibration transferred to the chassis, insulating. Materials were added to the cabin, the floor, the firewall, the doors. All began to include layers designed to reduce sound transmission. Glass became thicker, seals improved. Each change was small, but together they altered the acoustic environment inside the vehicle. At the same time, performance vehicles continued to develop their own sound characteristics. In these cases, sound was not only reduced, but shaped. Exhaust systems could be tuned, the length of pipe, the size of chambers, the path of gases, all influenced the final sound. Engines designed for performance often produced more pronounced exhaust notes, not necessarily louder, but more defined, more recognizable. A certain type of car became associated with a certain type of sound, and over time, this association became part of automotive culture. By the middle of the 20th century, the sound of a car had become more than just a byproduct. It had become part of its identity, not always deliberately, but undeniably. A large engine produced a deeper tone. A smaller engine produced a lighter sound. A performance car sounded different from a family car. And these differences were meaningful. They conveyed information. They created expectation. They shaped experience. Yet even during this period, the foundations of change were beginning to form. Technological development was accelerating. Engineering was becoming more precise. And gradually, new priorities began to emerge. Fuel efficiency, emissions, comfort. Each of these would influence how engines were designed, and in turn, how they sounded. As the automotive world moved further into the mid and late 20th century, the role of sound began to change in a more deliberate way. What had once been an unavoidable byproduct of mechanical operation was gradually becoming something that needed to be controlled, not removed entirely, but shaped, managed, refined. And this shift did not come from a single decision, or even a single industry. It emerged slowly, influenced by the changing environments in which cars existed. As cities expanded and populations grew, the number of vehicles on the road increased significantly. With that increase came a new kind of awareness. The sound of traffic was no longer occasional. It became constant, a background presence in everyday life. Engines idling at intersections, cars accelerating through narrow streets, vehicles moving through residential areas. The cumulative effect of these sounds began to draw attention, not to any one vehicle, but to the collective noise they created, and in response, governments began to act. Noise regulations were introduced in many parts of the world. These regulations did not focus on how an individual car sounded in isolation. They focused on limiting the overall noise produced by vehicles under specific conditions. Manufacturers were required to meet certain thresholds. Tests were developed, measurements standardized, and gradually the acceptable level of vehicle noise began to decrease. For engineers, this introduced a new challenge. Sound was no longer simply a characteristic of the engine. It was now something that had to be managed within defined limits. Exhaust systems became more complex. Where earlier designs had been simple pathways for gases to escape, modern systems incorporated multiple chambers and pathways. Sound waves would enter these chambers and reflect in specific ways. Some frequencies would be cancelled, others reduced. The goal was not just to make the car quieter, but to control the quality of the sound itself. At the same time, attention turned inward. The experience inside the vehicle became just as important as the sound outside. Drivers and passengers expected comfort, not only in ride quality, but in the acoustic environment. Long journeys were becoming more common, and constant noise, even at moderate levels, could lead to fatigue. Manufacturers responded by introducing more advanced sound insulation. Materials were selected not only for strength or durability, but for their ability to absorb sound. Layers were added to the body structure, within the doors, beneath the carpets, behind the dashboard. Each layer reduced the transmission of noise from the engine and the road. Engine mounting systems also evolved. In earlier designs, engines were often mounted directly to the chassis. Vibrations would travel freely through the structure of the car. This contributed to the sound experienced inside. By introducing flexible mountings, often made from rubber or similar materials, engineers were able to isolate the engine more effectively. Vibrations were absorbed before they could reach the cabin. The engine still moved, still produced sound, but less of that sound was transmitted to the occupants. As these changes accumulated, the character of engine sound began to soften. The sharp edges of combustion noise were reduced. Mechanical sounds became less pronounced. The overall experience became quieter, more controlled, more refined. At the same time, another significant influence was beginning to shape engine sound in a different way: emissions regulation. As awareness of environmental impact increased, governments introduced standards to limit the pollutants produced by vehicles. These standards led to the development and widespread adoption of new technologies within the engine and exhaust system. One of the most important of these was the catalytic converter. A catalytic converter is designed to reduce harmful emissions by facilitating chemical reactions within the exhaust gases. As gases pass through the converter, they interact with materials that promote these reactions. Pollutants are transformed into less harmful substances. The process is effective, but it also changes the physical structure of the exhaust system. Instead of a simple, open pathway, the exhaust flow must pass through a dense internal structure. This affects how sound travels. High-frequency components are reduced. The sharpness of the exhaust note is softened. The overall sound becomes more subdued. Additional components were introduced over time: particulate filters, exhaust gas recirculation systems. Each of these played a role in reducing emissions, and each also influenced sound. The exhaust system became less about allowing sound to escape and more about controlling what passed through it. At the same time, the combustion process itself was becoming more controlled. Earlier engines operated with relatively simple fuel delivery systems. Carburetors mixed air and fuel in a mechanical way. The process was effective, but not precise. Variations in mixture could lead to uneven combustion. An uneven combustion produces irregular sound. With the introduction of fuel injection systems, this began to change. Fuel could be delivered more precisely, in controlled amounts, at specific times. This allowed combustion to occur more consistently, more completely. The result was not only improved efficiency, but also a smoother sound. Less variation between combustion events, less irregularity, a more uniform acoustic pattern. Electronic engine management systems extended this precision further. Sensors monitored temperature, pressure, airflow, engine speed. This information was processed continuously. Adjustments were made in real time. The engine could adapt to changing conditions, maintain optimal operation, and as a result, produce a more consistent sound. Consistency in this context meant predictability. The engine behaved in a controlled manner. It did not surge unexpectedly. It did not produce irregular pulses. It operated smoothly, and that smoothness translated into sound. At the same time, manufacturers placed increasing emphasis on reducing vibration. Vibration is closely linked to sound. Where there is movement, there is energy, and where energy is transferred through a structure, it often becomes audible. By reducing vibration, engineers were also reducing sound. Balancing techniques became more advanced. Engines were designed to minimize internal forces. Components were arranged to counteract movement. In some engines, additional shafts were introduced specifically to balance internal motion. These balancing shafts rotated in opposition to the engine's natural movement, reducing vibration, smoothing operation, and in turn, reducing the sound associated with that movement. The cumulative effect of these developments was gradual, but significant. Cars became quieter, not dramatically at first, but steadily. Each improvement contributed a small reduction. Each refinement softened the overall sound. And yet, as this quieting took place, something else was happening. The natural variation in engine sound, the differences that once defined individual vehicles, were beginning to diminish. Engines were becoming more similar in their operation, more standardized in their design, more controlled in their behavior. Where once the sound of a car might have reflected its unique mechanical characteristics, it now reflected a set of shared engineering principles. Efficiency, compliance, refinement. These priorities shaped design decisions, and those decisions shaped sound. This was not necessarily a loss. From the perspective of comfort and usability, quieter vehicles represented progress. Driving became less tiring. Cabins became more peaceful. Background noise was reduced. For many drivers, this was a welcome change. But at the same time, the connection between driver and machine began to shift. Sound had once been a direct link, a way of understanding how the engine was operating, a way of feeling its character. As that sound became more controlled, more filtered, that link became less immediate. The engine was still there, still working, still producing energy, but its presence was less pronounced, less dominant. And as the industry continued to evolve, new technologies would take this transformation even further. As the quieting of engines continued through refinement, regulation, and improved control, another shift began to take place, one that would alter not only how engines performed, but how they sounded. This shift was not driven by sound itself. It was driven by efficiency, by the need to extract more performance from less fuel, by the pressure to reduce emissions while maintaining the expectations placed upon modern vehicles. And at the center of this shift was a change in how engines were designed. For much of automotive history, power had been closely tied to size. Larger engines produced more power. They drew in more air, burned more fuel, generated greater force. And with that force came a certain kind of sound, a deeper tone, a slower rhythm, a sense of mechanical presence. But as efficiency became more important, this approach began to change. Engineers began to explore ways to produce the same level of performance, or greater, from smaller engines. This concept became known as downsizing. And while it offered clear advantages in terms of efficiency, it also introduced changes in how engines operated and how they sounded. One of the most significant tools in this process was turbocharging. Turbochargers had existed for many years, particularly in aviation and performance applications. but their widespread use in everyday vehicles increased as efficiency demands grew. A turbocharger works by using the engine's exhaust gases to drive a turbine. This turbine is connected to a compressor, which forces additional air into the engine. With more air available, more fuel can be burned, and more power can be produced. This allows a smaller engine to achieve the output of a larger one. From a mechanical perspective, this is an elegant solution. It recovers energy that would otherwise be lost through the exhaust and uses it to enhance performance. But from an acoustic perspective, it introduces a significant change. In a naturally aspirated engine, exhaust gases exit the cylinder and travel relatively directly through the exhaust system. The pulses of combustion are transmitted with minimal interruption. The rhythm of the engine is clearly expressed. In a turbocharged engine, those exhaust gases must pass through the turbine. This process absorbs energy. It smooths out the sharp pulses of combustion. The turbine itself acts as a barrier, not a complete one, but enough to alter the character of the sound. The result is a softer exhaust note, less sharp, less defined. The individual pulses of combustion are less distinct. The overall sound becomes more uniform. At the same time, turbochargers introduce new sounds of their own. The spinning of the turbine creates a high-frequency whine. Air moving through the compressor produces a rushing sound. Pressure changes within the system can create subtle hissing noises. These sounds are different from traditional engine noise. They are less tied to the rhythm of combustion and more related to airflow and rotation. For some, these sounds add a new layer of interest. For others, they represent a departure from the familiar. Either way, they contribute to the changing acoustic identity of modern engines. As turbocharging became more common, engine sizes continued to decrease. Where once a larger engine might have been used to achieve a certain level of performance, a smaller turbocharged engine could now fulfill the same role. 4-cylinder engines replaced 6-cylinder engines. In some cases, 3-cylinder engines replaced 4-cylinder engines. These smaller engines operate differently. They often run at higher speeds. They rely on forced induction to produce power, and their combustion events occur in a different pattern. All of these factors influence sound. A smaller engine typically produces higher frequency sounds. The pulses of combustion occur more frequently. The intervals between them are shorter. The resulting sound is lighter, less deep. When combined with the smoothing effect of turbocharging, this creates an engine note that is more subdued, less pronounced. At the same time, the focus on efficiency has led to further changes in how engines operate. Direct fuel injection systems deliver fuel with precision. Variable valve timing adjusts airflow dynamically. Electronic control systems manage every aspect of operation. These technologies improve performance and efficiency, but they also contribute to a more controlled combustion process. Combustion becomes more consistent, more complete, less irregular, and as a result, the sound produced becomes more uniform. In earlier engines, slight variations in combustion could create subtle differences in sound. These variations added character. They made each engine feel unique. In modern engines, those variations are reduced. The engine operates within tighter parameters, and the sound reflects that consistency. Another important factor in this transformation is the increasing use of multiple gears and advanced transmissions. Modern automatic transmissions, including dual clutch systems and continuously variable transmissions, keep the engine operating within a narrower range of speeds. Instead of allowing engine speed to rise and fall in a wide, noticeable pattern, these systems maintain more consistent operation. In a manual transmission, the driver controls gear changes. Engine speed rises with acceleration, then drops as gears are shifted. This creates a clear, audible pattern, a rhythm that is easy to follow. In modern automatic systems, this pattern is less pronounced. Gear changes are smoother, less noticeable, in some cases almost imperceptible. Continuously variable transmissions remove the concept of fixed gears entirely. The engine can operate at a constant speed while the vehicle accelerates. From an acoustic perspective, this reduces variation. The engine sound becomes more stable, less dynamic, less tied to changes in speed. As these developments combine, the overall effect becomes clear. The modern engine is quieter, more controlled, more efficient, but also more consistent. The differences between engines are still present, but they are less obvious, less pronounced, more subtle. Where once the sound of a car might have been defined by its mechanical characteristics, it is now shaped by a broader set of priorities: efficiency, refinement, compliance. This does not mean that character has disappeared entirely, but it has changed. It has become less about raw mechanical expression and more about controlled performance. And as the industry continued to evolve, this process would extend even further. Sound would no longer be something that simply emerged from the engine. It would become something that could be shaped, adjusted, and even created independently. As the mechanical character of engines became more controlled, more refined, and more consistent, the role of sound entered a new and unfamiliar phase. For much of automotive history, sound had been a direct consequence of how an engine worked. It was not designed in isolation. It was not created separately. It emerged naturally as a reflection of combustion, movement, and mechanical interaction. But as those processes became quieter, more efficient, and more regulated, something else became possible. Sound could be influenced independently, not just reduced, but shaped. Not just shaped, but created. This shift did not happen all at once. It began in small ways, subtle adjustments, often unnoticed. Manufacturers began to explore how sound could be enhanced within the cabin. In some vehicles, microphones were used to capture engine noise from the engine bay. This sound was then processed and played through the car's audio system. The intention was not to create something artificial, but to preserve a sense of connection. As engines became quieter due to insulation and regulation, this system reintroduced some of the sound that had been lost. In other cases, the process went further. Rather than simply amplifying existing sound, manufacturers began to generate sound electronically. These sounds were designed to match the character of the vehicle, to respond to throttle input, to change with engine speed. They were not exact reproductions of mechanical noise, but interpretations, carefully designed to create a particular experience. From a technical perspective, this approach allowed engineers to separate sound from function. The engine could be optimized for efficiency, emissions, and reliability, and sound could be adjusted independently. This provided flexibility. But it also marked a significant change. Sound was no longer tied directly to mechanical reality. It had become an element of design. At the same time, attention turned to the outside of the vehicle. As engines became quieter, particularly at lower speeds, a new concern emerged: pedestrian awareness. In traditional vehicles, even at low speeds, the engine produced enough sound to signal its presence. The noise of combustion, the movement of components, the exhaust note, all contributed to an audible signature. But in quieter vehicles, especially hybrid and electric models, this signature was reduced, in some cases almost entirely absent. This created a potential safety issue. Pedestrians, particularly in urban environments, often rely on sound to detect approaching vehicles. Without that sound, awareness could be reduced, and so new regulations were introduced. Vehicles below certain speeds were required to produce an artificial sound, a consistent, recognizable tone, not loud, but sufficient to be noticed. These systems are known as acoustic vehicle alerting systems. They operate automatically, generating sound when the vehicle is moving slowly and fading out as speed increases and tire noise becomes more dominant. In this context, sound serves a functional purpose, not related to performance, not related to identity, but to safety. And alongside these developments, a larger transformation was taking place: the rise of electric vehicles. Electric propulsion represents a fundamental change in how vehicles operate. There is no combustion, no intake of air and fuel, no ignition event, no exhaust system. Instead, power is generated through electric motors. These motors convert electrical energy into mechanical motion. The process is efficient, smooth, and comparatively quiet. The sounds produced by electric vehicles are different in nature. There is the high-frequency tone of the motor, the subtle mechanical noise of gears, the sound of tires interacting with the road. the movement of air around the vehicle, but the dominant sound, the one that once defined the driving experience, is no longer present. The rhythmic pulse of combustion, the rise and fall of engine speed, the mechanical texture of moving components, these are largely absent. For some, this represents progress, a quieter environment, reduced noise pollution, a more peaceful driving experience. For others, it represents a change in connection. The relationship between driver and machine has shifted. Sound once provided feedback. It indicated effort. It conveyed speed. It communicated character. Without that sound, the experience becomes different. Acceleration may be faster, smoother, more immediate, but less accompanied by the cues that once defined it. In response, some manufacturers have introduced artificial sound into electric vehicles. Not for safety, but for experience. These sounds are generated electronically, delivered through speakers designed to respond to driver input. They may rise in pitch as speed increases. They may change tone under acceleration. They may be inspired by traditional engines or entirely new. In this way, sound becomes something that is created deliberately, a layer added to the experience, rather than something that emerges naturally. If we step back and consider the full progression, the pattern becomes clear. In the earliest days of the automobile, sound was uncontrolled, a direct reflection of mechanical operation. As vehicles became more refined, sound was reduced, managed for comfort, controlled through engineering. As technology advanced further, sound became something to be shaped, adjusted, filtered. And now, in the modern era, sound can be created, designed independently of the engine itself. This transformation reflects broader changes in the priorities of automotive design: efficiency, sustainability, comfort, precision. Each of these priorities influences how vehicles are built, and in turn, how they sound. There is also a deeper, more subtle aspect to this change. Sound is not only a technical characteristic, it is also an emotional one. For many people, the sound of an engine is associated with memory, with experience, with a particular time or place. A certain type of engine may recall a specific era, a particular journey, a familiar environment. As those sounds change, the associations change with them, not necessarily lost, but altered. And yet, it is important to recognize that sound has not disappeared. It has evolved, adapted, shifted in response to new conditions. Modern vehicles still produce sound, but it is more controlled, more intentional, less tied to the raw processes of combustion. And perhaps that is the defining characteristic of this transformation, not the loss of sound, but the change in how it is created. If we return to the question that began this journey, why cars do not sound the same anymore, the answer is not simple. It is not the result of a single invention or a single decision. It is the result of many small changes, accumulated over time. Noise regulations reduced overall sound levels. Emission systems altered the flow of exhaust. Turbocharging changed the nature of combustion pulses. Engine management systems refined operation. Insulation reduced transmission. Electrification removed combustion entirely. Each of these changes was logical. Each addressed a specific need. And together, they reshaped the acoustic landscape of the automobile. The sound of a car today reflects the world in which it exists, a world that values efficiency, comfort, sustainability, control. In earlier times, sound was a byproduct. Now it is a parameter, something that can be adjusted, measured, designed. And as with many aspects of engineering, this transformation has been gradual, almost unnoticed. There was no single moment when the sound changed, no clear point of transition. Instead, there was a series of small adjustments, each one subtle, each one incremental. And over time, those adjustments added up. The result is the sound of the modern car, quieter, more refined, more controlled, different but not necessarily diminished, because in the end, sound is only one part of the experience. It reflects the priorities of its time, and as those priorities change, so too does the sound. And so, the cars of today do not sound the same as those of the past, not because something has been taken away, but because something else has been added. precision, efficiency, intent. And as the automotive world continues to evolve, the sound will continue to evolve with it, quietly, gradually, almost unnoticed.